Hi, guys and gals. Sorry for that mix up here. All right. So today we're going to be talking about acids, bases, and the pH scale. We're actually going to start with the pH scale. So the pH scale is just a set of values that are going to tell you what whether something's an acid or whether something's a base. And the range goes from 0 to 14, 0 being the most acidic, and then like 6.9 being the least acidic, and then neutral. So this is where water would sit. Water is neutral. And then basic, the least basic thing would be like 7.1, and then the most basic thing would be 14. So let's look at some things that are acids and bases that you might know. Okay, so the most acidic thing on this chart would be a pH of 1. So like our stomach acid, the hydrochloric acid that's in our stomach is about the pH of 1. Lemon juice, which is citric acid, that's about a 2. Soda and Coke, pop, Coca-Cola, Pepsi, that ranges around a pH of 3. We have tomato juice can be acidic. And actually, this is kind of odd. Most people think milk is basic. Milk is actually just slightly acidic. Pure water we have right here in the middle. Neutral, 7 is neutral. So go ahead and pause the video here and go ahead and make your fill in your pH table, your pH scale on your notes. You're going to write in the numbers. And then if you want to add some of the common acids and bases here, you certainly can. Make sure you list that 1 to 7 is acidic or an acid, and that 7 to 14 is a base. Okay, after you've got that done. So bases are things that have a little bit higher pH. This is like bleach, ammonia, that's like pine sol if you've ever used that to clean your floors, hand soap, baking soda. Those things are kind of typically your bases. All right, so acid. So under your acid, so your notes. So you're going to write down these 4 bullet points. All right, so acids have a pH less than 7, like we saw before. And they are very good at damaging metals. So a lot of times we think of when we watch movies that acids are super bad. We see people being melted by acid. Well, acids actually aren't too bad to us. I mean, heck, it's in our stomach. So how bad could it be? And that's a pretty strong acid, an acid of pH of 1. So acids aren't too bad, but they're really bad for metals. They tend to have a sour taste. That's why lemon juice is sour, because it's an acid. So acids have a sour taste, right? And that's where we kind of get the sour flavors in nature, like lemons and limes and things like that. Okay, and then this is the most important thing. The reason an acid is an acid is that when it's added to water, it releases these hydrogen ions. Okay, this is called this will conjugate with water to create an ion called hydronium, which is H3O+. All right, so you're also going to write down this basic equation for an acid. You're going to write down HCl. This is hydrochloric acid. When it's dissolved in water, it'll produce these hydrogen ions and these chlorine ions. Here's a list of some common acids. Here's hydrochloric acid. This is called This is phosphoric acid. Sulfuric acid, sorry. Man, I got it all wrong. Sulfuric acid. This is hydrofluoric acid. And finally, this was the phosphoric acid. This is phosphoric acid. And you can see all acids start with the letter H. So that's one way you can know something's an acid. Okay, so on your notes, you're going to list some common acids here. I've kind of grayed out the bases over here, so go ahead and jot down 3 examples of acids and write down their picture, try to draw their picture, and give them a label. So you're going to draw battery, make sure you write battery down. So pause this video and jot 3 of those down. So bases, what we saw, right, they're greater than 7. Now, these are the dangerous ones, right? They react strongly with organic material. So that's you. So its bases are the things that are going to really damage you. If you got acid in your eye, that would be bad for sure. You don't want to do that. But you have about a minute to wash out your eyes before you have permanent eyesight damage. With a strong base, like lye or sodium hydroxide, you could have permanent eye damage within 10 seconds. So bases are the things that we want to be really careful with. These are the things that'll eat your clothes, like chlorine bleach and things like that. It'll put a hole in your clothes and things like that. So bases are bad for humans. Okay, they also taste bitter. Right, these will be like bitter tasting things. And unlike acids, when acids are added to water, they produce hydrogen. When bases are added to water, they produce this ion that you might be familiar with because we've used it before. This is called the hydroxide ion. Okay, here's an example. Go ahead and write down this basic equation. Get it? Basic equation, because we're talking about bases. Anyways, sorry. All right, so sodium hydroxide, when you dissolve it in water, you'll get sodium ions, but then you'll also get these hydroxide ions, and that's what makes something basic, is these hydroxide ions floating around. Here's a list of some common bases. Here we have sodium hydroxide. Here we have calcium hydroxide, lithium hydroxide, and aluminum hydroxide. And they all contain more or less of these hydroxide ions. So the more hydroxide you get, the stronger the base can be, right? It depends on some other factors, but the more hydroxide ions you actually have, the more basic it'll be. So here again, this is for your notes. Go ahead and jot down 3 examples of some common bases. So we have blood, baking soda, ammonia, bleach, drain cleaner. That's really bad if you got drain cleaner in your eye. It could cause permanent damage. And then soap, right? Your body soap ranges from anywhere from a pH of 10 to a pH of 12. And the last thing we're going to talk about is something called an indicator. And so what a pH indicator is if you just have a clear liquid, you can't see the pH. So you don't know if it's dangerous. You don't know if it's acidic or basic. So sometimes in chemistry, we use indicators to show us when something becomes neutral, or when something becomes acidic, or when something becomes basic. Cabbage juice is actually a really good natural indicator. And so if you put cabbage juice into, like, let's say some lemon juice, it'll turn pink. But if you put that same cabbage juice in like a cleaning solution, like bleach or something, it'll turn yellow. And you can kind of see how it changes color based on the pH of the liquid. Okay, so the indicator is a substance that changes color in the presence of an acid or a base. All right, so that's it for pH and acids and bases. Now go ahead and choose a couple activities and come up and take the quiz. All right, thanks guys.